Imagine an airplane flying smoothly above the clouds, carrying hundreds of passengers across continents. Now imagine that same plane suddenly grounded, not because of a technical failure, but because the engine it relies on might no longer be available. This isn't science fiction. Earlier this year, reports emerged that the US could suspend engine supplies for China's C919, a jet that has already safely flown over 1 million passengers since entering service. The C919 is more than just an airplane. It's China's bold step into the global commercial aviation arena, designed to compete with giants like Boeing and Airbus. But without engines, this ambitious program could face a production halt in as little as 3 years. This raises urgent questions. Why would the US risk upsetting one of its largest aviation customers? And with the US holding such leverage, can Russia really step in to fill the gap? Or is this just talk? At the heart of it all is a simple truth. The engine is the heart of an aircraft. Without it, the wings, fuselage, and cockpit are useless. Today, we're going to unpack this high-stakes story, exploring supply chains, geopolitics, and the race for aviation independence, to understand why a single component could shape the future of global air travel. To understand why the C919's engines are such a big deal, we need to zoom out to the heart of global engine production, the miniature Villers-Roux plant in France. Spread across more than 100 hectares, that's over 140 football fields, this facility is a powerhouse, producing more than 1,600 aircraft engines each year. These engines don't just stay in France. They power over 800 aircraft worldwide, meaning that more than 70% of all single-aisle jets in operation rely on this plant. The engines for the C919 come from CFM International, a joint venture owned 50% by France's Safran and 50% by the US's GE Aerospace. That 50-50 split is crucial. It gives the US the authority to halt engine exports if it chooses, no matter how advanced China's aircraft program has become. So far, China's COMAC has ordered 760 LEAP-1C engines to equip roughly 380 C919 planes. But here's the gap. Only 18 planes have been delivered, leaving around 360 engines still pending. This is a perfect example of how global supply chains can become a geopolitical lever. A single decision in Washington or Paris can ripple across continents, affecting production schedules, airlines, and even the passengers who rely on these planes. In short, the C919 isn't just about China building a jet. It's about navigating a global network of high-tech suppliers, each with its own rules, politics, and stakes. And in this network, engines are more than parts. They're the lifeblood of international aviation. The power of the US over the C919 program became very clear earlier this year when the Department of Commerce began suspending export licenses for American companies supplying components to China. This wasn't just about engines. It affected a wide range of critical aircraft parts: avionics systems, hydraulic controls, auxiliary power units, landing gear systems, and navigation equipment. In short, almost every major system in the aircraft could be impacted. The real-world consequences of such restrictions are immediate and tangible. Imagine a factory ready to deliver hundreds of planes, suddenly unable to get the parts it needs. Delivery schedules are delayed, production lines slow down, and the ambitious goal of competing with Boeing and Airbus suddenly faces a hard stop. Some American media even predicted that if engine supplies were fully cut, the C919 program could cease production within 3 years. But this is more than a production issue. By enforcing these restrictions, the US risks alienating its own suppliers who rely on the rapidly growing Chinese market. They risk lost revenue, broken contracts, and the chance that China will accelerate its own domestic alternatives. Politics and aviation collide here. A decision made in Washington has immediate technical and economic consequences across the globe. At this point, the story raises a bigger question. Why would the US take such a risky step against one of the world's largest aviation customers? The answer lies not in airplanes, but in a hidden resource critical to modern technology: rare earths. Beneath the surface of this aviation conflict lies a less obvious but far more strategic factor: rare earth elements. These are a group of 17 metals that might sound obscure, but they're indispensable in modern technology. From smartphones and electric vehicles to wind turbines and even fighter jet engines. Without rare earths, Much of today's high-tech world simply doesn't function. China dominates this market. While it holds about 36% of the world's rare earth reserves, it controls over 90% of global refining capacity, especially for heavy rare earths, the kind critical for advanced military and aviation technologies. In other words, even if the US or other countries have the raw materials, China is the only nation capable of processing them efficiently at scale. This dominance has real consequences. U.S. defense contractors and Pentagon suppliers have struggled to source rare earths from outside China. For example, a manufacturer producing drone components tried negotiating with alternative suppliers multiple times and failed. Prices have spiked dramatically. Samarium, used in fighter jet engines, skyrocketed nearly 60 times in a few months. When it comes to aviation, this matters because modern jet engines rely on magnets and materials derived from rare earths. By restricting engine exports to China, the U.S. may have thought it could slow the C919 program, but it quickly became clear that America itself is highly dependent on Chinese rare earths. The attempt to leverage aviation exports collided with a hard reality: supply chains are global, and critical materials like rare earths are concentrated in just a few hands. This sets the stage for a dramatic turn in the story. If the U.S. holds back engines, will Russia step in to fill the gap? And could China finally take control of its own aviation future? As tensions over engine supplies mounted, Russia stepped into the spotlight. Through Rostec, one of its largest state-owned industrial groups, Russia publicly offered to provide China with aircraft engines, including the PD-14, a modern turbofan already powering Russia's MC-21 short-to-medium-range jets. Rostec isn't a minor player. Globally, it ranks fifth among aircraft engine manufacturers, trailing only GE, Pratt & Whitney, Rolls-Royce, and CFM International. Its product line spans everything from smaller commercial engines to heavy-duty military power plants. In terms of overall technological strength, Russia is considered second only to the United States, meaning its offer is serious, not just symbolic. The PD-14 itself is a high-thrust modern engine designed to compete with the Boeing 737 and Airbus A320 families on international routes. If successfully integrated into the C919, it could serve as a viable replacement for the US-supplied LEAP-1C. However, there are still big questions. Can Russia deliver engines in the quantity China needs? Can they meet the strict international safety standards? And how quickly could integration happen without disrupting production? Russia's offer adds a new layer to the story, a potential lifeline for China, but one that comes with technical and logistical hurdles. It also underscores how geopolitics and technology intertwine. When one door closes, another may open, but not without challenges. While the world debated U.S. restrictions and Russia's potential support, China quietly accelerated its own solution, the CJ1000A engine, a fully domestic alternative to the LEAP-1C. This isn't just a prototype. It's designed with 13 tons of thrust, composite fan blades, and a digital control system, bringing fuel efficiency close to the Western engines it aims to replace. Progress has been rapid. The CJ1000A has completed 150 hours of core endurance testing and is now being installed on C919 aircraft for high-altitude flight trials. The goal is to achieve certification from China's Civil Aviation Authority by 2026, with mass production expected in 2027, 3 years earlier than previous projections. This development carries huge strategic weight. By creating a domestic engine, China reduces its reliance on foreign suppliers, strengthens the C919 program's long-term stability, and gains bargaining power in global aviation. It's a statement: China doesn't just want to assemble planes, it wants to control every critical component from fuselage to engine. The CJ1000A embodies more than technology. It's a bet on independence, a safeguard against geopolitical shocks, and a signal to the world that China is ready to compete on its own terms. Even with the CJ1000A making remarkable progress, the path to full commercial use is still long and complex. A new engine isn't just about design and initial testing. It must undergo thousands of hours of stable operation to prove reliability. Engineers also need to build a complete maintenance system, a network for spare parts, and ensure that pilots can operate the new engines safely and efficiently. Scaling production for commercial aviation is another hurdle. Unlike smaller prototypes, mass-producing engines for hundreds of planes requires precise coordination across supply chains, quality control, and logistics. Even minor errors can cause delays or safety issues. This phase is where technical innovation meets political and economic reality. Any disruption, whether from regulatory challenges, supply chain shortages, or international pressure, could slow the rollout. But success would mean China finally has an independent world-class engine, reducing vulnerability to foreign restrictions and opening the door to greater influence in global aviation. In short, the CJ1000A represents both a technological milestone and a geopolitical statement. It's proof that even when the world's largest powers try to exert control, determination, planning, and innovation can chart a different course. The story of the C919, the U.S. export restrictions Russia's offer, and China's domestic CJ1000A engine, is more than an aviation tale. It's a high-stakes chess game of technology, geopolitics, and strategy. One country's decision to restrict engines created ripples across continents, while Russia's potential involvement offered a possible lifeline. Meanwhile, China moved decisively to secure its own future, developing a homegrown engine capable of powering its ambitions. The takeaway is clear. The C919 isn't just a plane. It symbolizes China's rise in commercial aviation and its push for independence from foreign technology. Over the next few years, the decisions made by the United States, Russia, and China will determine whether the C919 and CJ1000A reshape the global aviation landscape. If you found this deep dive into aviation, geopolitics, and technological strategy intriguing, make sure to subscribe and turn on notifications. We'll continue bringing updates on China's aviation breakthroughs, global industry shifts, and the high-stakes decisions shaping the skies of tomorrow. The future of aviation is unfolding now. Don't miss it.